Let us consider the problem on regression lines of y on x and x on y. Along with that, I have taken finding correlation coefficient also. Here there is a data for x. Each value of x, y is given to us. X is taken as the independent variable and y is the dependent variable. For this data, we have to find out the correlation coefficient r as well as the regression lines of y on x and x on y. Firstly, we take the mean value of x. It is the sum of all the values of x, that is summation x divided by the number of data points here. Number of data points is 10 and summation x, and adding all the values of x we are going to get 70, and when we divide this by 10 it is 7. Same way y bar is going to be summation y divided by n. When we add all the values of y here, it is 150 divided by the number of values here is 10. That on simplification gives you 15. Knowing the values of mean of x series and mean of y series, we have to subtract each value of x from the mean of the x to get capital X values. Same way, each value of y will be subtracted from mean of y to get capital Y. And then the construction of the table looks like this here. Each value of x is subtracted from x bar. We have got it as 7. 1 minus 7 is minus 6. Like that it is done for all the values, and each value of capital X is squared and added here, and we are getting it as 204. In same way, each value of y is subtracted from the mean, which is 15, and then the value is squared and added. Summation y square value is 818, and the product capital X multiplied by capital Y, minus 6 multiplied by minus 7 is 42. Like that, each value of capital X is multiplied with capital Y to get summation xy, which in turn is 360. With the help of this, now we can find out the correlation coefficient. It is given by summation xy divided by square root of summation x square multiplied by summation y square, which is equal to summation xy value. We got it as 360 divided by square root of 204 multiplied by 818. That's about the values, and simplification of this gives you 0.8812. This is the correlation coefficient, and remember, correlation coefficient should always lie between -1 to 1. And now, knowing the correlation coefficient, we can find out the regression lines. Before finding that regression lines, we'll take the regression coefficients, and the formula for that regression coefficients, which we have discussed in the previous video, is byx is given by r into sigma y by sigma x, or alternatively we can write byx is equals to summation xy divided by summation x square. This is for the reason r is nothing but summation xy divided by n into sigma x sigma y. This is the alternate formula for r. On substitution of this and simplifying, we get byx equal to summation xy divided by summation x square. Same way, bxy is summation xy divided by summation y square. And this is the alternate formulas and quite easy to use. Therefore, byx summation xy value, which we have got it for this problem as 360, and summation x square is 204. Therefore, the value of that is 1.7647, which on simplification. And similarly, bxy value, it is summation xy 360 divided by 818, which on simplification becomes 0.4401. This is the value of bxy. This is considered to be the regression coefficient of x on y, and byx is considered to be the regression coefficient of y on x. Knowing the regression coefficients of y on x and x on y, we can now frame the regression lines. the regression lines of y on x. First I will take it. It is given by the formula y minus y bar is equals to byx multiplied by x minus x bar. Y bar is known to us, it is 15, which we have calculated. Byx is available, it is 1.7647, and x bar is also available, it is 7, which on simplification gives you y is equals to 1.7647 multiplied with x, and 1.7647 is multiplied with minus 7, and then it is subtracted from 15, which on simplification takes 2.6471. This is the regression line of y on x, where this value is, this slope is considered to be the regression coefficient. Same way, now we can take the regression lines of x on y. It is given by the formula x minus x bar is equals to bxy multiplied by y minus y bar. And as we know, the value of x bar is 7, bxy we have calculated it as 0.4401, and y bar value is 15, which on simplification gives you 0.4401 times y multiplied with negative 15 and subtracted from plus 7. This is going to give us the positive value, that is 0.3985. This is simplification of that particular numbers, and this is what we call it as the regression coefficient of x on y, that is 0.4401, and the equation which we have written as x equals to 0.4401 times y plus 0.3985 is taken to be the regression line of x on